Hey everyone, my name is George Kobar. I'm a product marketing director for Elasticsearch. And today we'll be discussing the difference between Elasticsearch and AWS OpenSearch. Before we jump in, I want to provide a little context or history of where the two originated from. So Elasticsearch was created back in 2010 by Shai, who later founded the company Elastic. So Elastic created Elasticsearch, and it's amazing to think that was 13 years ago. So we have a teenager on our hands. So now OpenSearch project was created by AWS, which was forked off of an old Elasticsearch version, which is 7.10.2, which was released back in November of 2020. And on July 2021, they released their 1.0, which was generally available at that time. And since the GA of OpenSearch, both products have had different trajectories. Elasticsearch has approximately 12 new releases and about 400 original features. And in comparison, OpenSearch has had 10 releases and about 100 plus features, which mostly are comprised of things that are playing catch up to Elasticsearch and Kibana. And these catch-up features in OpenSearch are called the exact same thing in Elasticsearch. While I do agree with Oscar Wilde that imitation is the sincerest form of flattery, these features are not the same, which can be very misleading. For example, cross-cluster search is a feature where you could search across multiple clusters that are located in different locations. Obviously, you want to have the best search experience for your users, and sometimes having a cluster within that particular region where a customer is searching on, they're going to get the best search experience. So you get search clusters that are located in different cloud providers, or clusters operated on premises, or in between. And for OpenSearch, they call this feature also cross-cluster search. But the problem is you can't connect to self-managed OpenSearch clusters. So there is no hybrid or connecting between multiple different cloud providers. And you can't use custom dictionaries for SQL, which is very different than what we provide on Elasticsearch. So again, Elasticsearch and OpenSearch, they are not the same. So let's go ahead and go over some of the other differences. We'll start off with the architecture differences. With some of the new features being added to OpenSearch, they're being delivered as plugins. For example, the security analytics solution, index management, securing OpenSearch is done by a security plugin. And I know right now that plugin is still using the default change me or some of the default certificates. So be sure to change those passwords right. There are different ranking plugin, and some of the metrics analysis is done by the observability plugin. So there are a lot of advantages and disadvantages to this new plugin approach. The advantages is OpenSearch can extend OpenSearch without really modifying OpenSearch or going into the Lucene library. And each plugin has a very specific role, so the developer can focus on what that plugin will do. But there are some disadvantages of a plugin architecture that can start to add up. Plugins do not have the advantage of being at the same layer with OpenSearch and the Lucene libraries itself. And this can have performance issues, especially at scale. And with every new version of OpenSearch, there becomes a question of sustainability and operability among the different plugins. So while this isn't really a problem specifically to the users of OpenSearch, the maintainers will have to deal with a level of complexity of testing each plugin for the correct operation. And some plugins won't be available as they're upgrading through. They have to kind of play that catch-up piece. So with the Elasticsearch, these solutions are built natively into the stack. So these features are built directly into Elasticsearch. As the largest maintainers of the open source project for Lucene, the search libraries that Elasticsearch depend on, a lot of these features are built at this native layer. So we think about our security solution that's built into Elasticsearch, and Kibana is able to surface those UIs. Same thing about our observability or index lifecycle manager. A lot of these aspects are built directly into the stack. And what's great also is that each new feature is built for Elasticsearch that directly benefits all these turnkey solutions like search, observability, and security, which are really built for speed, scalability, resilience, and of course, increased functionality. So if we take a moment to look at these features that are built into Elasticsearch, we'll see a theme that we're pushing the boundaries of what Elasticsearch is capable of. So as an example, we've made great strides on increasing storage efficiency. So we all know data is growing at an exponential rate, and of course, the cost to store it. Most organizations need to make a difficult decision of what data to keep, what data to delete, or what data to archive. And Elastic has been on a mission to optimize Elasticsearch to use less storage and store data on low-cost object storage. So organizations no longer have to make the difficult decision of what data to delete, or what data to keep. After all, you shouldn't outgrow good data. And one of the things that we've done is decouple storage from compute with our searchable snapshots. So the typical warm tier node with 64 gigs of RAM manages up to about 10 terabytes, and a cold tier will handle twice as much as 20 terabytes. And the frozen tier node will jump to about 100 terabytes. This is about a 1 to a 1500 RAM storage ratio. In the frozen tier, there's a lot of great blogs on it. It's very performant. Our frozen tier is compared to other people's hot tier. So definitely check that out. And some of these great features that we've released, for example, the match only text can save up to 10% on storage efficiencies. Doc value only fields save up to 20%. And of course, the combination of synthetic source and routing and sorting by TSID have a combination of 70%. So if all of these features apply to you, if you start off at 100 terabytes worth of data, that data will shrink to about 30 terabytes. So again, there's a lot of great efficiencies, and we're continuing releasing new things to increase storage efficiency. And if we look at better memory efficiency, there's a huge project internal to Elasticsearch to push the bounds of scalability. So much so that we actually changed our sharding strategy. Now, new sharding efficiency now supports up to 3,000 indices per 1 gig heap of master eligible nodes. So this capability significantly reduces the amount of resources a shard uses to really help the master node be able to manage the data. And of course, if every idle shard is using less memory, we 92% memory savings on idle shards. That memory could be best used for searches or indexing. So this capability significantly lowers heap consumption per field of data and optimized shard requests. And of course, reduce memory use for composite aggregation and reduce memory per map field to 1 kilobyte per field. Again, these are some of the great things that we've done to really reduce the amount of memory that Elasticsearch consumes. And of course, Elasticsearch is already known to be lightning fast. We're always looking to push into those boundaries wherever possible. So if you take a look at some of these great features here, we can see that customers can scale 20x more data at the same cost while having fast search for data stored in S3. We also can look at data histograms. They're 8 times faster for logs and for other analysis. And data histograms are really useful for investigating trends or failures. So Elastic pre-computes all of those rounding points for a data histogram and turns into a range aggregation, leading to that 8x speed improvement that was introduced in 7.11. And range queries are 20x times faster. So we can see here, there's a lot of different aggregations, geogrid aggregations. Even using what's called the random sampler aggregation, you can get a vast improvement of speed and scale into Elasticsearch. And again, these are things that are exclusively to Elasticsearch. So let's talk about the future of search and talk about some of the advancements that Elastic is making to make this the best experience or best search possible. If you haven't had a chance to listen to Matt Riley's keynote, he talks a lot about vector search and also about the same topic of the future of search, and I highly recommend it. So he mentions that search technology is rapidly changing, and it's been on an acceleration in the emergence and innovation of these different technologies. and information retrieval. So machine learning with large language models and vector search in particular, are improving relevance that matches the expectations of what customers want. And vector search is powering technologies like image search. So taking a picture and saying, I want these pair of shoes. Where can I buy these pair of shoes? Personalization. Customers also viewed this, or people that are also purchased this, for recommendations. Sentiment analysis. Show me only positive reviews, or better yet, show me negative reviews. That way I could reach out to that particular customer and offer them an apology or some way to make that negative into a positive review. All of these things are being fueled by all of these things help bring relevance to your customers. And we're making these capabilities to any developer to apply vector search without becoming an expert in AI or machine learning, or really leaning on the data science team if you have them. So we're allowing you to bring your own model with PyTorch. And of course, you could either have your own model and decide to train your own data. You could go ahead and go to different communities like Hugging Face to be able to use the models they have within their community. Or you can also bring your own vector embeddings directly into Elasticsearch. So we provide a lot of flexibility to make sure that we're democratizing vector search, allowing all developers to have access to this technology without a deep expertise that was previously needed. And we're also reducing the steps that are needed to have semantic search available to you. And we're putting that into a single endpoint. So what we're doing is we're consolidating these two API calls into a single one, making implementation of vector search far more easier. So we're going to vectorize the query and also run the search, which in this case is just the nearest neighbor search. For the longest time, BM25F or keyword search has been the backbone of many search systems, including Elasticsearch. But traditional search can miss out on an important context and sentiment. Without the extensive manual of tuning of the traditional search engines, text search can miss out on even the most simple synonyms. So a lot of these systems have to be constantly updating new synonyms, and that obviously takes a lot of time and resources away from you. And as discussed, there are a lot of great advancements with vector search and what kind of capabilities it could bring to you. However, it can also miss out on important keywords, especially names or specific industry terms or jargon, or even rarely used words can be missed, which will not provide that best search experience. However, together, the BM25 or text search with vector search provides the best of both worlds. And Elastic is the best place for this type of capability. OpenSearch has a lot of this hybrid functionality, but with several caveats. So if you're creating an index, that's something that you have to set a setting within that index. Also you have to specify different algorithm types when creating a mapping. So if you're not really experienced on what algorithms you should do, that's kind of a barrier for you to get started. And of course, the memory management is complex, which takes special consideration with some of the AN data structure. And if you're maintaining an external to you C++ library, can lead to challenges, including stability and just ensuring that's secure. So we've also announced a serverless offering, and so has OpenSearch. So let's kind of talk about some of the differences between the two. So serverless is just a cloud native deployment model that allows developers to build and run applications without managing the infrastructure. And so talking with a lot of our customers and users, we learned that a lot of people just want to consume Elasticsearch as a service, just as a console. They don't have to worry about managing the infrastructure or worrying about shards or what types of nodes and the index lifecycle management. And that's why we're building Elastic Serverless. It's the next generation managed service. But what's also crucial about this is we're building it to be a consumption-based pricing. And what's great about this is we know that traditionally Elasticsearch, the index and search are tied to the same node. Well, we're breaking that up into individual services. So if you need more indexing or if you need more search, you should be able to auto scale one or both of those down to 0. So not only we're breaking the elasticity of compute and storage on these different services, but we're actually looking at that autoscale zero and the consumption-based pricing. And there's going to be some great sessions at ElasticON on this topic. So definitely look out for those. If we take a look at the OpenSearch serverless side, again, this is a little tongue-in-cheek, but when they say serverless, is it really serverless? Because there's a monthly minimum price of $691 per month that you have to pay. So it's not truly a consumption-based model. And right now, there's no plans for auto-scaling to zero. But you're not paying resource-based pricing. And there's still a lot of that configuration, like network policies and resource types. So there's a lot of that operational overhead. And it's funny because this meme, is coming from the OpenSearch community. Is OpenSearch using serverless just as a buzzword? In my opinion, I think so. So again, Elasticsearch and OpenSearch are not the same. And you can see that just in the different tracks and features that they're releasing. And again, as the creators of Elasticsearch, we're very dedicated to making sure that you're using less resources, faster search, and bringing the new search technologies that you come to depend on to run your business. Thank you so much for coming to my talk. I hope you really appreciated it, and I'll see you later.